Hello everyone. In this video, we will see how to determine ABCD parameters, means generalized constants of medium transmission line using nominal T method. Consider an equivalent per phase diagram of medium transmission line with nominal T model. For this determination of ABCD parameters, first of all consider standard expressions of Vs and Is, means sending end voltage and sending end current, in terms of ABCD equations, as it can be written as Vs is equal to A into Vr plus B into Ir, and Is is equal to C into Vr plus D into Ir. Equation number 1 and 2. As we are considering this transmission line as a two-port network, this equation 1 and 2 written like, suppose this is the transmission line with the inputs Vs and Is, and we are getting voltage Vr and Ir as output. And if we apply the ABCD parameters to this transmission line, we get it in the form of Vs Is is equal to constant matrix into Vr and Ir. And these constants are represented with these generalized constants as A, B, C, D matrix. Using this matrix, we can write equation 1 and 2. As if we get the values of A, B, C, D, and if we know the value of Vr and Ir, we can easily calculate the value of Vs and Is to determine performance of transmission lines. Hence, using this method, we are calculating the values of ABCD for given circuit. Now, for this, we have to derive the expressions of nominal T method for medium transmission line in a such a way that equations can be comparable to equation 1 and 2, so that by comparing the values, we get the values of ABCD parameters. So let us start. First of all, we are going to apply KVL to loop 1. We are considering this as a loop 1, this as loop 2. We are applying KVL to loop 1. By applying KVL to loop 1, we can write Vs is equal to Vc plus Is into Z by 2. Equation number 3. Then we are applying KVL to loop 2. We can write the expression for loop 2 as Vc is equal to Vr plus Ir into Z by 2. Equation number 4. And now apply KCL to node, which can be written as this as a P node. Node P, we can write incoming current Is is equal to outgoing current Ic plus Ir. Equation number 5. But if we see, Ic can be written as Vc upon Xc, or here we can write total impedance across it is Zc. So we can write Vc upon Zc as a Vc into Y, where Y is nothing but shunt admittance and given by 1 by Z. Y is equal to its inverse of impedance and named as shunt admittance. It is measured in Siemens. Now IC can be written as, we can put the value of Vc from equation 4 as Vr plus Ir into Z by 2 into whole multiplied with Y. Now IC can be written as YVR plus Z by 2 IR into Y. Equation number 6. This value of IC in equation number 5. To get the value of IS, put equation 6 in equation 5. As Is becomes equal to Ic, we can write y into Vr plus z by 2 Ir into y plus Ir from equation this. So we can write this YVR plus we can take common IR into bracket ZY by 2 plus 1. Equation number 7. Now, if we get this equation as a IS, it is comparable to equation number 2. IS is equal to CVR means YVR plus DIR means IR into this one will be value of D. Along with this, we will determine the value of Vs and then at the end we will compare with the standard expressions. From equation 3 and 7, Vs and 7 means this Is, we can put these values in equation number 3 to get value of Vs. From equation 3, 4 and 7, we get the value of Vs as by putting the value of Vc as Vr plus Ir into Z by 2 plus Is from this expression number 7, we can write YVR plus Ir. We can multiply or we can put the previous value as Ir plus Z by 2 plus IR into Z by 2 from equation 3, 4 and 7. Now, as it can be simplified as VR plus IR Z by 2 plus Y Z by 2 VR plus IR Z square Y by 4 plus IR Z by 2. We can collect the VR terms together and IR terms together. VR plus YZ by 2 VR plus this Z by 2 and Z by 2 we can write it as a IR into Z plus IR Z square Y by 4 together. So we can get common as a VR 1 plus YZ by 2 plus IR as a common Z plus Z square Y by 4. So this is Vs. Equation number 8. By comparing equation 7, 8 with equation 1 and 2, we get the value of A is equal to 1 plus YZ by 2. B becomes this one Z plus Z square Y by 4. C becomes from equation 7 comparing equation 2 Y as a C and D as a ZY by 2 plus 1. So we can write C is equal to Y and D becomes 1 plus YZ by. These are the generalized constants, ABCD constants. We can write it in the form of matrix equation as VSIS is equal to 1 plus YZ by 2 Y, Z plus Z square Y by 4 and D 1 plus YZ by into VR IR. Also, we can write the units of ABCD parameters as 1 plus YZ. The unit of Y is 1 upon ohm and Z is ohm. So it becomes unitless. Similarly, we can write here also for D 1 plus YZ by 2 is unitless. For B, we can write the unit of B is Z is ohm plus ohm square into 1 upon ohm. So that get cancelled and here get unit as a ohm and the unit of Y is Siemens. For this we can also verify whether the circuit is symmetrical and reciprocal. For this we can write condition for symmetrical as A equal to D equal to 1 plus YZ by 2. Hence the circuit is symmetrical. Second condition we can check whether circuit is reciprocal. Reciprocal condition as as AD minus BC should be 1. And if we put the values of this AD and BC here as 1 plus YZ by 2A, D is similar, 1 plus YZ by 2 minus BC is nothing but Z plus Z square Y by 4 into C is Y. And if we write this by multiplying, we will get 1 YZ by 2 plus YZ by 2 plus this term and this term Y square Z square by 4 minus ZY plus Z square Y square by 4. So this YZ by 2 YZ by 2 becomes 1 YZ and this YZ get cancelled. Hence we can write this get cancelled and Y square Z square by 4 and Y square Z square by 4 will get cancelled, and now we get it as a 1. So AD minus BC equal to 1. Hence circuit is reciprocal as well as symmetrical. From these expressions we can determine the values of ABCD parameters of medium transmission line using nominal T method. Here we determine the value of Vs and Is in the form of standard expression. By comparing, we are getting the values of ABCD. If we know the values of ABCD and the values of receiving end side as a VRIR, we can calculate the performance parameters of transmission line as a voltage regulation and efficiency. Thank you.